Good morning. Let's start a new chapter, chapter number 6 of class ninth, lines and angles. This will be according to new syllabus. And in this chapter, we'll learn about the properties of lines and angles. Okay, so let us start. We will start with basic terms and definitions. Basic terms and definitions. Let's start with line. Line is, we all know from the Euclid's geometry, that it is breadthless length. And it can be extended on the either side indefinitely, infinitely. Okay, so this is our line. Next is ray. When this line has one endpoint, one starting point, or then this is called ray, and the other point will be endless. That means it can be extended infinitely. Example of ray is sun ray. Sun ray starts from sun and move infinitely. That is why it is called sun ray. It has one starting point and it will move infinitely. Okay, next is line segment. So in ray we have one endpoint, in line segment we have two endpoints. When there is two endpoints in a line, then this is called line segment, and we can name it as A and B. Because it has two endpoints, this is also called truncated line in the Euclid geometry. Okay, so when a line has two endpoints, it is called line segment. Next, now if we see a line segment A and B, there are many points which lie on this line, because line is a collection of points, infinite points. Okay, there will be many points like C, D, E. Okay, when all these points lie on the line, on the same line, then these points are called collinear collinear points. Okay, all the points which lie on the same line are called collinear points. When there is a point which does not lie on the same line, then C and F are non-collinear points. Or D and F. So C, D, E are collinear, and F is C, D, F are non-collinear points. Okay. Next, we'll recall angles. What is angle? When two rays start from a point in different direction, then the distance between the two rays is measured in degree, and this is called angle. The point, the starting point of the angle is called vertex, and these two rays are called arms. Okay, so uh, in angles, these rays or arms can be on any direction. So according to their directions, we have different names to these angles. First, it is acute angle. Okay, before understanding different angles, let us refresh how to measure degree or angle. Let us suppose this is our angle and we want to measure it. What we will do, we will take protractor In protector there will be a center point. On this center point we'll put this vertex, and on this line we'll take this arm. We'll match this arm to this line. Okay, from here we will see on the protector this will be transparent, and we'll see where this other arms matches with the line. Let us suppose it matches with 60°. There will be numbers here 0, 10, 20, 30, 60, like this. It matches with 60°. So the angle between these two will be 60°. Okay. So now when we measure the angle and we find that let us suppose the angle be x. When we measure the angle we find that the angle is greater than 0°. 0° will be when both the arms both the arms on the same line. When the angle is greater than 0° but is less than 90°. 90°. Okay. So when it is greater than 0° but less than 90°, so this range is called acute angle. Any angle within this range is called acute angle. Next, right angle. Okay, we have understood the acute angle. When we measure an angle and it matches to the 90°, that is the angle is both the arms are perpendicular to one another, then the angle is called right angle. That means let us assume this is y and y is equal to 90°. Then this is called right angle. If you see here that for acute angle there is a range, that is 0 to 90°. All the angles are called acute angles, but for right angle it is only one value, that is 90°. If it matches then only it will be called right angle. Third, obtuse angle. Again here is angle, but in this time if any angle is greater than 90°, let us assume this is z. Any angle that is greater than 90° but less than 180°, it is called obtuse angle. What is 180°? This line is called 180° from here to here. So from 90 to 180, within this range, all the angles are called obtuse angle. That means 120, 130, 133, 154. All these angles are called obtuse angle. Fourth, when both the arms are opposite to one another, they will make an angle 180° and are called straight angles. Let us assume it is S. It is called straight angle or 180° when both the arms are opposite to one another. Next, when one arm is making angle more than 180° with another arm, then the angle is called reflex angle, is greater than 180°. Sorry, M is greater than 180° but less than 360°, because on 360° angle will be 0. Okay, so in this range all the angles are called reflex angle. And when both the arms are on one another, arm number 1, arm number 2, both are on one another, so this will be 0° and 360° both. Next, let us suppose there is angle this, and there is vertex from which three rays are originating like this. Let us name them A, B, C, D. Okay, so there will be two angles formed. One is this one and another one is this one. When the sum of two angles is 90 degree, that means when angle ABD plus angle DBC is equal to 90 degree, then these angles are called complementary angles. Okay, when the sum of two angles is equal to 90 degree, then the angles are called complementary angles. Okay, similarly, let us assume this is the vertex, these are two rays, and these are two angles. Okay, and again name them. This is B, this is A, C, and D. Any point on the ray, these are any point on the ray. So when the sum of two angles is 180 degree, okay, that means angle ABD plus angle DBC is equal to 180 degree, then these angles are called supplementary angle. Okay, when the sum is 90 degree, they are called complementary angle. When the sum is 180 degree, they are called supplementary angles. These angles are called supplementary angles, these angles are called complementary angles. Okay, next, now we have seen two angles like this. Again we'll name them B, any point on the ray, any point on the ray, like this. Okay, so these angles which are forming here, like angle ABD and angle DBC, these angles are called adjacent angles. They are called adjacent angles. Why they are called adjacent angle? So for two angles to being adjacent angles, there are three conditions. One, they should have common vertex, which is here B. They should have common arm, which is BD. Third and most important, the non-common arm should not be on the same side, should not be on same side, they should be on opposite sides or different side, whatever you like to say. So these are the three conditions which makes two angle adjacent angles. Okay. Third, next, this is the vertex, these are the arms, same, this is B, this is A, this is D, this is C. Again, we know that these are adjacent angles, right? Why? Because they satisfy the three conditions. What are the three conditions? They have a common vertex B, they have a common arm BD, and the non-common arm are on the opposite side or on the different side, okay, of the common arm. So these are adjacent angle. If the angle is adjacent, if the angles are adjacent and the sum of angles make 180-degree, then they are called linear pair of angles. That means if angle ABD plus angle DBC is equal to 180-degree, then they are called, these are called linear pair of angles. Okay, we can also say that if line ABC is a straight line and the angles are adjacent, then they are called linear pair of angles. Okay, next, let us assume these are two lines which are crossing each other at a point O. The lines are A, B, C and D. These are the two lines which are crossing each other at point O. We know that two lines, when they cross each other at one point, that is called O. So they will make angles to one another, like this one, that is angle AOC and angle DOB. They are called vertically opposite angle. And angle AOC will be equal to angle DOB, because vertically opposite angles are equal. They make pairs of vertically opposite angle. Also, if you see here, this angle and this angle will also be vertically opposite, that is angle AOD and angle COB. They are also making vertically opposite angles. Next, intersecting lines and non-intersecting lines. Okay, so when two lines cross each other, they cross each other at a point. When they cross each other, they are called intersecting lines. Okay, no matter where they cross, if they cross each other here, they are called intersecting lines. If they cross here, they are called intersecting lines. So wherever they cross, they are called intersecting lines. No matter where the position of the lines are or the direction of the lines are, they are called intersecting lines. Okay, second, non-intersecting lines. So when two lines do not intersect with each other, like this, they are not intersecting with each other, they are called non-intersecting lines. But if you extend them indefinitely, they will intersect at some point. They are called non-intersecting lines but with a condition that they will not be extended. Okay, then there are lines which will never intersect each other and will maintain a common difference from the starting to the end, and this distance will be, the distance here will be perpendicular always at different points, common perpendiculars. That means this will be equal to this, the distance between this will be equal to this. Therefore these lines are called parallel lines because they maintain a common difference from the starting point to the end point, to infinite on both sides. Okay, next, pairs of angles. So what we have learned here is that there is a line, there is a vertex O, then there is a line A, ray A with a point A, then another ray with a point B, and there is another ray with a point C. So this angle and this angle, we know that angle AOC, angle BOC, and angle AOB, there are three angles made from the lines. Okay, we can write this as angle AOB is equal to angle AOC plus angle BOC. We can see it here, it is equal to angle BOC, and if and only if angle AOC plus angle BOC is equal to 180 degree, and therefore angle AOB will be equal to 180 degree, they are called linear pair of angles. Okay, and because since angle AOB is making 180 degree, we get our first axiom 6.1. Okay, which says that if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. What does it say? If a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. So basically what this axiom is saying, that if a ray stands on line, then the sum of these two angles will be 180 degree. Okay, now we will get some examples of adjacent angles and we will deduce some interesting things. Adjacent angles, all the examples will be adjacent. Let us assume this one, there is a point O vertex, there is a ray, this we name it a point on the ray A, a point on the ray B, on the point on the ray C, or this one B and this one C. If this is 30 degree and this is 60 degree, then they are adjacent to one another, and because their sum is 90, they are also called complementary angles. Okay, they are called adjacent angle and complementary angle. Okay, another example of adjacent angle, when we are finding adjacent angles, we have to always remember the three conditions. What are the three conditions? That both the angles should have a common vertex, both the angles should have a common arm, and the non-common arm should be on the other side of the common arm. We have also seen example of linear. Here we can see that this is adjacent angle, but because their sum is 180-degree, therefore it is also called linear pair of angles and also called supplementary angles. So here we can see three things. These angles are adjacent angles. Second, they are linear pair of angles. Third, they are supplementary angles because the sum of two angles is 180-degree. Okay, next. They are also, this is A, this is B, and this is C. This angle is also adjacent because again it is satisfies all the three conditions. From the figure what we have seen here, we get our axiom 6.2, and that is, if the sum of two adjacent angle is 180-degree, then the non-common arm of the angles form a line. That is the linear pair of angles. What is the axiom? If the sum of two adjacent angles is 180-degree, then the non-common arms of the angles form a line. Since they form a linear pair axiom, and this axiom is also called linear pair axiom, since they form a linear pair of angles. Okay, next, theorem 6.1. What does this theorem says? If two lines intersect each other, then the vertically opposite angles are equal. This is what I have told earlier, that when two lines intersect each other, let us assume that this is the vertex, these are the lines, and we name a point A on this lines and point B, point C, and point D. We have named them these lines. What this theorem says is, if two lines intersect each other, then the vertically opposite angles are equal. Okay, let's start with the proof. For proofing, we know that the two lines intersect each other, so let us assume AB and CD are the two lines that is intersecting at a point O. So what we are getting here is, we are getting two pairs. The first one is this and second one is this. That is right. First is angle AOC and angle BOD, and second is angle AOD and angle COB or BOC. Now see, ray OA stands in line CD. Ray OA is on line CD. We already know that it is a line. Therefore, angle AOC plus angle AOD will be equal to 180 degree, because it forms a line, a linear pair of angles. Okay, again we can write angle AOD plus angle BOD is equal to 180 degree, because AB, since AB is a line and AOB is making linear pair of angles. Let us assume this is equation number 1, this is equation number 2. Now if we take from 1 and 2, we can write, since both are equal to 180 degree, therefore they has to be equal. So angle AOC plus angle AOD has to be equal angle AOD plus angle BOD. This implies that, or this means angle AOC has to be equal to angle BOD. Similarly, we can prove that angle AOC will be equal to angle BOD. So we can prove angle AOD is equal to angle BOC by similar axiom. So hence, since the both angles are equal, we have proved that when two lines intersect at each other, then the vertically opposite angles are equal. Example number 1. In figure, lines PQ and RS intersect each other at point O. This is our diagram. PQ and RS intersect at O. This is P, this is Q, this is R, this is S. They intersect at O. If POR, angle POR, that means this angle, upon ratio angle ROQ, that means this angle, are in a ratio, if angle POR are in a ratio angle ROQ 5:7, find all the angles. We have to find all angles. Okay, solution. Since angle POR plus angle ROQ is equal to 180 degree, because of linear pair of angles, they form 180 degree. Therefore, what we have what is given in the question is that these two angles are in a ratio, and let us assume their multiple is x. So angle POR is in ratio with angle ROQ, and they are in ratio of 5:7. So 5 plus 7 is equal to 12. So whole 12 is 180 degree. We have to find the part. Therefore, angle POR will be 5 upon 12 into 180 degree. This will be 15 into 5. This will be 75 degree. And angle ROQ is equal to 7 upon 12. It is into 180 degree. It is 105 degree. Therefore, angle POR is equal to 75 degree and angle ROQ is equal to 105 degree. Okay. Since these lines intersect each other, therefore their vertically opposite angles for angle POR, vertically opposite angle will be angle QOS will be equal to 75 degree, and angle ROQ will have a vertically opposite angle POS will be equal to 105 degree, because they are vertically they are equal. Okay, so we have found all the angles. Example number 2. Example number 2 says, in figure, ray OS stands on the line POQ. This is P, this is Q. So OS stands on the line POQ. Ray OR and ray OT are angle bisectors of POS and SOQ. OR and OSOT are the angle bisector of angle POS and SOQ respectively. Find angle ROT. What we have to find? We have to find angle ROT. Okay. Let us, before finding solution, let us find what is the given thing. Ray OS stands in line POQ. Therefore, angle POS plus angle SOQ will be 180 degree. Okay. Let us assume that angle POS is equal to X. Okay. So X plus angle SOQ is equal to 180 degree, or X is or angle SOQ will be equal to 180 degree minus X. Now since OR bisect angle POS, therefore since OR bisect angle POS, therefore angle ROS will be half of angle POS. That means angle ROS will be half of X. Similarly, angle SOT will be half of angle SOQ. That means angle SOT will be half of 180 minus X, or we can say that 90 minus X upon 2. Okay, I hope until now you have clear. Now angle ROT is equal to angle ROS plus angle SOT. Therefore, angle ROT is equal to X upon 2 plus 90 minus X upon 2. So equal to, since both are same values and on other signs, different signs, they both will deduct each other. So angle ROT will be equal to 90 degree. Example number 3. Example number 3 says there is a diagram. We'll first draw the diagram. This is a point from which 4 rays are coming out. Okay, so question says OP, OQ, OR, OS are 4 rays. So we have to prove angle POQ plus angle QOR plus angle SOR plus angle POS is equal to 360 degree. Solution. Here what we have, what is given in the question, that these are the 4 rays here which are originating from point O. Okay, and we have to prove that all these 4 angles, angle number 1, 2, 3, 4, they are total making angle 360 degree. So by the visual itself we can see that it is 360 degree, but we have to prove it. But whatever theorems we have and axioms we have, it is difficult to prove this because we don't have any straight line here, right? If we have a straight line, then only we can prove it. Okay, so what we'll do, we'll assume a straight line. We'll make a straight line. What we'll do, we'll again make this diagram and we will assume one straight line from Q. You can make it from anywhere, but just for the, because Q is horizontal, that is why we are making it from Q. So we are assuming that this ray is extended backwards and we name it T. Okay, so TOQ becomes straight line. Okay, since angle TOQ becomes a straight line, angle TOQ will become equal to 180 degree, right? And angle TOP plus angle POQ will be equal to 180 degree, since they are make a linear pair. Similarly, now we have made this one. Now we will take this one. Similarly, angle TOS plus angle SOR plus angle ROQ also makes 180 degree, right? Why? Because angle TOS plus angle SOQ is equal to 180 degree, linear pair, and angle TOS plus this angle SOQ is made up of two angles, that is SOR and ROQ, what we have written here. So this is what we get. Okay, so if we see here that we name it point equation number 2 and this one equation number 1. If we add equation 1 and 2, what we get here? We get angle TOP plus angle POQ plus angle TOS plus angle SOR plus angle ROQ is equal to 180 plus 180. So this gives us angle T. This gives us, see here, this is the imaginary line. So this angle is TOP and TOS. This both becomes POS, right? This angle TOP and angle TOS. This both becomes angle POS. Okay, means what? Angle TOP plus angle TOS is equal to angle POS, right? Because we have assumed this line, so we will remove this line now. So angle, this will become, this both angle will become angle POS plus angle POQ plus angle SOR plus angle ROQ becomes 360 degree. Hence proved. Now we will start exercise number 6.1, page number 76. Question number 1. Question number 1 says, we have a diagram. We name it A, B, center O, this is C, this is D, and this is E. Okay, this is the diagram in question number 1. It says lines AB and CD intersect at O. What does it say? Lines AB and CD intersect at O. If angle AOC plus angle BOE is equal to 70 degree, and angle BOD is equal to 40 degree. What we have to do now? We have to find angle BOE and reflex angle COE, right? So this is the given part, and this is what we have to prove. Always write this so that it gives you a clarity what is given in the question and what we have to find. Okay, now since AB and CD is a line and they intersect each other, therefore, and this angle at O, they intersect each other at O, and angle AOC plus angle BOE, but that means this angle and this angle is, sum of these two angles is 70 degree, and this angle is 40 degree, right? This is what we have right given. So AB is a line, this is given. Since AB is a line, therefore angle AOC plus angle COE plus angle BOE is equal to 180 degree. Why? Because of linear pair. How do we make it linear pair? Because we can write AOE as angle AOE, angle AOE plus angle BOE is equal to 180 degree, and we can break this AOE into AOC and COE. That is why this is the linear pair. Okay, since this is 180 degree and angle AOC plus angle BOE is equal to 70 degree given, therefore angle COE becomes 180 minus 70 is equal to 110. Right? Now we have angle COE. Right? Now consider line CD. When we take line CD, then we take angle COB plus angle BOD is equal to 180 degree. Again linear pair, and we can write this angle COB as angle angle COE plus angle EOB or BOE plus angle BOD is equal to 180 degree, because this angle makes the sum this, right? Therefore what we have now, we have the value of angle COE from equation 1. From 1 we have, this is 1010, and we have BOD plus angle EOB or BOE plus 40 degree, this is given equal to 180 degree. So angle BOE is equal to 180 minus 150 is equal to 30 degree. So angle BOE becomes 30 degree. This is the first part of the question. Okay, What is the second part? We have to find reflex of COE. So here we already have angle COE is equal to 110 degree, and we already know that for any angle this is the angle, and the remaining part here, this is called reflex angle. So whole complete angle is 360 degree. If we minus the angle part, we get the reflex angle part, right? So we have the angle part here, angle COE. So reflex of angle COE becomes 360 minus 110 is equal to 250 degree. So this is the second part of the question. Okay, so we got both answers. Question number 2. In question number 2, we have a figure. This is a straight line, this is a line, and this is perpendicular. Sorry. This is point O. This is perpendicular. This is X. This is Y. M, N, P. Okay. So in this figure, what is given? It is given line XY and MN intersect at O. That XY and MN are lines and they intersect at O. If angle POY is 90 degree, angle POY is 90 degree, and A ratio B is equal to 2 ratio 3, find, that means to prove, C. In the question, this angle is A, this angle is B, and this angle is C. Okay, so what we have to do? We have to find C. So from the given information, we know that XY and MN are lines, right? Since XY is a line, therefore angle XOP plus angle POY is equal to 180 degree, linear pair, right? And we can write angle XOP as angle XOM plus angle MOP plus angle POY is equal to 180 degree, right? Therefore angle XOM plus angle MOP plus 90 degree is equal to 180 degree, or angle XOM plus angle MOP is equal to 180 minus 90 is 90 degree. So this is what we get, that angle XOM, that means angle A plus angle B is equal to 90 degree. And another information given in the question is A ratio B is 2/3. So let us consider, let the multiple be x. Okay, so we assume that the multiple is x. So 2x plus 3x by 5 is equal to 90 degree. Okay, so 5x is equal to 90 into 5 and x is equal to 90 degree. Therefore angle A is equal to 2x upon 5 is equal to 2 into 90 upon 5 is equal to 5 on the 5, 8 the, that means 36. Angle A is equal to 36 and angle B is equal to 3x upon 5 is equal to 3 into 90 upon 5, 3 into 18 is equal to 54 degree, angle B. So we got angle A as 36 degree and angle B as 54 degree, right? Now we have angle B. Now it is also given that line MN is a line. Therefore angle MOX plus angle XON is equal to 180 degree. That means angle B plus angle C is equal to 180 degree from linear pair is equal to angle C is equal to 180 minus 54 is equal to 126 degree. So angle C is equal to 126 degree. Hence proved. Next, question number 3. In question number 3, we have a diagram. My drawing is not that good. We have a line here and we have two lines which makes it a triangular shape. This is line, this point is Q, this point is R, and this point is P. Okay, this is S, this is T. This is given in the question. From the figure, angle PQR is equal to angle PRQ. Okay, then this is given. Or to prove, what we have to prove, that angle PQS is equal to angle PRT. That means we have to prove this angle is equal to this angle. Okay, here we see that SQR R, T are points on same line. Therefore, they are collinear points, right? This is what we get. And angle PQS is equal to angle PRT. This is also given. Let us take angle Q as origin, point Q as origin. We form angle SQP plus angle PQR is equal to 180 degree linear pair, right? That means angle SQP is equal to 180 minus angle PQR. This becomes our equation number 1. Similarly, angle PRT is equal to 180 minus angle PRQ. This is given. I made a mistake. Okay. Since from equation 1 and 2 we can see that since PQR is equal to, let us assume angle PQR is equal to angle PRQ, it is given, is equal to x. So from equation 1 and 2, angle SQP is equal to 180 minus x and angle PRT is equal to 180 minus x. Since both are same, we can say that from equation number 3 and 4, we can say that angle SQP is equal to angle PRT. Why? Since RHS of equation 3 and 4 are equal, therefore LHS will be equal. Question number 4. In question number 4, we have this diagram. This is center O, this ray is A, this point on the ray is B, this point on the ray is C, and this point on the ray is D. Okay, and this is X, this is Y, this is W, and this is Z. What is given in the question? If X plus Y is equal to W plus Z, X plus Y is equal to W plus Z, then prove that AOB is a line. What we have to do? We have to prove AOB is a line. Now, to prove any ray or any points a line, what we have to do? We have to prove that this makes 180 degree. If AOB, if angle AOB makes 180 degree, we can prove that this is a line, right? Okay, from the question we see that x plus y is equal to w plus z, and angle x plus y is angle BOC plus angle AOC is equal to angle BOD plus angle AOD. These are equal, and to make these angles equal, and we can see from the figure that angle x plus angle y plus angle z plus angle w is equal to 360 degree, because they complete the whole figure. They all form 360 degree. So if we add these four, angle BOC plus angle AOC plus angle BOD plus angle AOD, they has to be 360 degree. And this is equation number 1, this is equation number 2. So from 1 and 2, there is only one condition where equation number 1 and 2 satisfies. That means these two angles will be equal to these two angles. That means if they are equal, and since they are equal, they will divide. Let us assume these two angles is equal to this. We can put in equation number 2. So angle BOC plus angle AOC, plus we'll put the value of this from equation 1. So angle BOC plus angle AOC equal to 360 degree. So 2 angle BOC plus angle AOC is equal to 360 degree, and angle BOC plus angle AOC is equal to 360 by 2 is equal to 180 degree. Since angle BOC and angle AOC makes 180 degree, therefore AOB is a line. Why? Because angle BOC and plus angle AOC equal to 180 degree. This is linear pair, and this is linear pair, therefore it is a line. Therefore AOB is a line. Question number 5. We have a diagram. Here it is a ray line which has two endpoints P. This is R, this is Q, this is R, and this is S. Okay, what are the given things in question number 5? That POQ is a line. This is the first thing. Ray OR is perpendicular to line PQ. Ray OR is perpendicular to line PQ. Okay, and OS is another ray that is lying between OP and OR. Okay, and these are the three information that is given, and we have to prove angle ROS is equal to half of angle QOS minus angle POS. This is what we have to prove. While proving these questions, these types of questions, we have to remember that what we have to prove and the on left hand side and right hand side. So these are the things we have to bring on left hand side and right hand side, okay, to prove these kinds of questions. So first of all, what we will do, we will take things which are given, like since angle POR plus angle ROQ is equal to 180 degree because of linear pair, okay, and OR is perpendicular to OQ, that means they are making 90 degree an angle. Therefore angle POR plus 90 degree is equal to 180 degree. Okay, therefore angle POR is equal to 90 degree, or we can write angle POR as angle POS plus angle ROS is equal to 90 degree, right? So you can see here that we want ROS and we want POS. This is what we get here. Okay, again we don't want this 90 degree, right? So in place of this 90 degree we can write that since it is given that angle ROQ is equal to 90 degree, we can write angle POS plus angle ROS is equal to angle ROQ. We can write this, right, from here, because it is perpendicular. OR is perpendicular to OS, a PQ. Okay, also we can write POS plus angle ROS is equal to, we can take this angle as angle SOQ minus angle ROS. This is what we wanted. We didn't want it ROQ, and we can write it here from, because from, if you want to find this angle, we can write this angle minus this angle. This gives us this angle. So ROQ is SOQ minus ROS. We can write this as this. Also we can write this is angle ROS, this is ROS. So we bring this ROS to right hand side, left hand side. So 2 angle ROS is equal to angle SOQ minus angle POS, or 2 ROS, 2 angle ROS is equal to angle QOS, SOQ is QS minus angle POS, or angle ROS is equal to 1 by 2 angle QOS minus angle POS. Hence proved. Question number 6. Question number 6. Question number 6 is, it is given that angle XYZ is equal to 64 degree. What is given? XYZ is equal to 64 degree. And XY is produced to point P. XY is produced to point P. Draw a figure from the given information. If ray YQ bisects angle ZYP, find, or to prove, angle XYQ and angle reflex angle QYP. Okay, these two things we have to find. First we have to find XYQ and reflex angle QYP, but before that we have to draw the diagram. It is given that XY is produced from to point P. That means XY is a line that is produced to point P. We take XY, XY, it is produced to point P. Okay, then what is given? XYZ is 64 and YQ bisects ZYP. XYZ is 64, XY, and we make an angle 64, and Z, this is angle 64 degree. Okay, and YQ bisects ZYP. So this is our Q, it bisects ZYP. So this is our diagram. Okay, proof. Since XYP is a line, therefore angle XYQ plus angle QYP is equal to 180 degree. Linear pair, right? And because they are a linear pair, therefore we can write, let us assume angle ZYQ and angle QYP is equal to X. Let us assume is equal to M, because X is already written there. Let us assume it is M. Okay, and since the both angles are equal, we can write here as M. Okay, therefore from equation number 1, this XYQ can be written as angle XYZ plus angle ZYQ plus angle QYP is equal to 180 degree. So XYZ is 64 degree plus M is equal to 180 degree. So 2M is equal to 180 minus 64. 2M is equal to 116, or M is equal to 58 degree. Okay, so this becomes 58 and this becomes 58, right? Now what we have to find? We have to find angle XYQ. So angle YQ is equal to angle XYZ plus angle ZYQ is equal to 64 plus 58. So angle XYQ is equal to 112 degree. This is the first answer, that angle XYQ is equal to 122 degree. Next, what we have to find? We have to find the reflex of QYP. We have to find the reflex of QYP. So reflex of QYP angle. We already know what is the reflex, 360 minus the angle. So reflex will be 360 minus angle QYP equal to 360 minus 58 is equal to 302 degree. So reflex of angle QYP is equal to 302 degree. This is our answer, and here we have completed exercise number 6.1. Next is lines parallel to the same line. Okay, here you can see that in the diagram given below we have three lines, line L, M and N, which is intersected by a transversal T. So T is our transversal. L, M, N are lines, and L is parallel to M and L is parallel to N. This is also given. So we can say that from the name itself, lines which are parallel to the same line. We can say that, see that here L is parallel to M and L is also parallel to N. From here we can see that when a transversal intersect the lines, the corresponding angles, when the lines are parallel, the corresponding angles are equal. So from this we can deduce that angle 1 is equal to angle 2, because the corresponding angles of parallel lines are equal. And here we can deduce angle 1 is equal to angle 3. We can see here in the both equation number 1, equation number 2, that these angles are equal to the same angle. So from here we can say that angle 2 is equal to angle 3, right? And since angle 2 is equal to angle 3 and they are intersected by the same transversal, therefore line M should be parallel to line N. How? Because of the converse of corresponding angle axiom. From this we get our theorem, which says lines which are parallel to the same lines are parallel to each other. Okay. Let us start with example number 4. In the following diagram, if PQ is parallel to RS, this is our PQ, line PQ, and it is parallel to RS, line RS, and angle M, X and Q is equal to 135 degree, and angle MYR is equal to 40 degree. We have to find X and Y. We have to find X and Y. That means we have to find this angle. Now, to solve this question, one thing is very clear, that this angle can only be found when we make it a triangle, either a triangle like this, but then we don't know that the position of X and Y are same. They can be different. So, and the interior angles and this angle will not be possible to find. right? So what we will do, what can be done, this is a thinking process which when while solving questions of angles and lines we have to do, right? What we can do here is we can make an imaginary line which passes through point M, right? This is the imaginary line which passes through point M, and we name it A and B. Now we have three lines, that is line PQ, line AB and line RS, right? And PQ will be parallel to AB and PQ will be parallel to RS. Therefore, AB is also parallel to RS from the theorem 6.6 which we have learned earlier. Now, angle QXM plus angle XMB is equal to 180 degree. Why? That means this angle QXM, this angle, and XMB means this angle. This is equal to 180 degree. Why? Because for parallel lines, interior angle on the same side of a transversal, interior angles on the same side of transversal make 180 degree. Therefore, angle XMB will be 180 minus angle QXM is equal to 180 minus QXM is given in the question. QXM or MXQ is the same thing. It is 135 degree. Therefore, angle XMB is equal to 45 degree, right? And because this is equal to 45 degree, and it is passing through the transversal, therefore angle BMY will be equal to angle MYR. That means angle BMY will be equal to angle MYR. Why? Because alternate angles of parallel lines of alternate angle, because AB parallel to RS and they are alternate angles. Therefore, angle BMY will be equal to 40 degree. Therefore, what we have to find? We have to find angle XMY, and XMY is equal to XMB plus angle BMY is equal to XMB is 45 degree plus BMY is 40 degree is equal to 85 degree. This is our answer. Example number 5. If a transversal intersects two lines such that the bisectors of the pair of corresponding angles are parallel, then prove that the two lines are parallel. What we have here is that this transversal AD is intersecting two lines PQ and RS, okay, and the bisectors of corresponding angles, which is this one. This is the corresponding angles of both lines, and the bisectors are BE and CG. These are BE is parallel to CG is given, and they are the bisectors of corresponding angles. That means angle ABE is equal to angle QBE, and angle BCG is equal to angle SCG, right? Or we can say that angle AB is equal to half of ABQ, and angle BCQ is equal to BCG is equal to half of BCS, angle BCS. And BE is parallel to CG, and AD is a transversal. Therefore, angle ABE has to be equal to angle BCG, because corresponding angle axiom, right? Substituting, let us assume this is equation number 1, this is equation number 2, and this is equation number 3. Substituting 1 and 2 in 3. Substituting equation 1 and 2 in equation number 3, right? So what we will do, we'll put the value of ABE and BCG in 3. So half ABQ is equal to half BCS, half cancel. So ABQ is equal to BCS. Since they are the corresponding angles of lines PQ and RS, and transversal AD. Since the corresponding angles are equal, therefore we can say that PQ is parallel to RS. Converse of corresponding angle axiom. Okay. Example number 6. Example number 6 says, in this figure, AB is parallel to CD. Line AB is parallel to CD, and line CD is parallel to EF. Okay. Also, what is given here? First, we will write the given things. Given is AB is parallel to CD and CD is parallel to EF. This is given. What else is given? EA is perpendicular to AB. Okay. What else? If angle BEF is equal to 55 degree, that means this angle, this BEF, that means this angle is 55 degree. Find the value of X. Find X, Y and Z. This is the process to attempt any question. Given then we have to write to proof, then we'll write proof. Okay, so here we can clearly see that since CD is parallel to EF, therefore angle FED plus angle ED will be equal to 180 degree, right? So angle 55 degree plus angle D is equal to 180 degree. Therefore angle D is equal to 180 minus 55 is equal to 125 degree. So angle D is equal to 125 and that is equal to Y. Okay, and since you can see AB is parallel to CD, therefore angle X will be equal to angle Y. Why? Because of corresponding angle, right? Therefore angle X will be 125 degree, right? Now we have this. Now we know that since AB is parallel to CD and CD is parallel to EF, therefore AB is parallel to EF. We already know from the theorem. Therefore angle EAB will be V plus angle FEA will be equal to 180 degree. Why? Because interior angle of the same side of the transversal are equal and EA is a transversal, right? This EA is a transversal to AB and EF, right? So on the same side this angle and this angle will be equal, right? So EAB is 90 degree plus FEA is equal to 180 degree. So angle FEA is equal to 90 degree. Okay, since angle FEA is equal to 90 degree and angle FEA is made up of angle FED plus angle DEC is equal to 90 degree. We can write FED as 55 degree plus Z is equal to 90 degree. So Z equal to 90 minus 55, that is 35 degree. Okay, so let's start exercise number 6.2. Question number 1. In this question in figure, below, if AB is parallel to CD and CD is parallel to EF and Y ratio Z is equal to 3:7, then we have to find X. So while attempting these kind of question, we already know that we have to write first the given things which are given in the question, so that we get a clear view. First thing that is given is AB is parallel to CD. This line AB is parallel to CD and CD is parallel to EF. This line CD is parallel to EF. What else is given? That angle Y and Z are in a ratio. Y and Z are in a ratio of 3:7. Then what we write? We write what we have to find, or what we have to prove. We have to find here, find X. Okay. Now we'll write solution. To find X, first we have to find the value of Y and Z. For that, what we have, Y and Z angles are on line C and D, CD and EF, right? Therefore, we will take, since lines CD is parallel to EF, therefore let us assume that O is an angle on O is an angle on XBD. The name of this angle is O. So this becomes O angle. O angle is equal to 180 minus Y. Why? Because it is a straight line and it is a linear pair. Because of linear pair, this becomes 180 minus Y. So this becomes 180 minus Y, right? Now, since CD is parallel to EF, which is written here, which is given here, therefore angle O will be equal to angle Z. Why? Because of corresponding pair. Of two parallel lines. Therefore, 180 minus Y will be equal to Z, or Y plus Z is equal to 180 degree. This becomes our equation number 1. Now, it is given in the question that Y and Z are in a ratio of 3:7. Let us assume their multiple be A. No, M. Their multiple be M, because A is already there in the question. That is why. Therefore, the ratio of Y with Y will become 3 upon 3 plus 7 into M, and Z will become 7 upon 3 plus 7 into M. We already know from our previous classes. So Y will become 3 upon 10 M and Z will become 7 upon 10 M, right? And we put, when we put the value of Y and Z in equation number 1, what we will get? 3 upon 10 M plus 7 upon 10 M is equal to 180, or 10 M is equal to 180 into 10, or M is equal to 180. So we have M equal to 180. Therefore, value of Y will become 3 upon 10 into 180, and Z will become 7 upon 10 into 180. So Y will become 54 and Z will become 126, right? We got the value of Y and Z. What is the value of Y? Z 126 and Y 54. Now again we know that AB is parallel to CD. It is given in question. Therefore, sum of interior angles of a transversal intersecting through two parallel lines is the sum of those interior angles. Therefore, angle X plus angle Y is equal to 180 degree. We have to find angle X plus angle Y is 54 equal to 180 degree. Therefore, angle X is equal to 126 degree. 180 minus 54. So this is the value of X. Question number 2. In the figure given below, if AB is parallel to CD, that means these two lines are parallel. EF is perpendicular to CD. This line is perpendicular to CD. And angle GED, that means this angle, is 126 degree. Then we have to find angle AGE, angle GEF and angle FGE. Okay, so what we will do first, we'll write the given things. What is given? That AB is parallel to CD. This is given. What else is given? EF is perpendicular to CD. Okay, and angle GED is equal to 126 degree. What we have to find? We have to find angle AGE, angle GEF and angle FGE. Okay, let us start with the solution. We have to find what we have. First we will write in the diagram what we want to find. We want to find AGE, this angle, GEF, this angle. This angle we will make it bolder, FGE, and this angle. These three angles we have to find. Okay, we know that angle GED equal to 126 degree. It is given, right? And angle FED is equal to 90 degree because EF is perpendicular to CD. And angle GDE is equal to angle GEF plus angle FED. Therefore, when we put it in the equation above, angle GEF plus angle FED is equal to 126 degree. We have to find angle GEF plus FED is given 90 degree equal to 126 degree. Angle GEF becomes 126 minus 90. Angle GEF becomes 36 degree. So we have find this is 36 degree. Right? Now what we have to find? We have to find AGE. AGE. So for finding AGE and FGE and this angle, we know that GE is a transversal to lines AB and CD. Therefore, alternate angles will be equal. That means this will be equal to this. That means angle AGE will be equal to angle GED. Therefore, AGE is equal to 126 degree. Again, since AGF makes linear pair, therefore AGE plus FGE will be equal to 180 degree. We know AGE is 126 plus FGE is equal to 180 degree. So FGE is equal to 180 minus 126 is equal to 54 degree. FGE becomes 54 degree and AGE becomes 126 degree and GEF becomes 36 degree. Hence proved. Question number 3. In the figure given below, if PQ is parallel to ST, PQ is parallel to ST and PQR, this angle is 110 degree and RST is 130 degree. Find QRS. What we have to find? We have to find this angle. So what is given in the question? That PQ is parallel to ST, angle PQR is 110 degree, angle RST is equal to 130 degree. What we have to find? We have to find angle QRS. Solution. Okay. There is one more thing given in the question, that is hint. Draw a line parallel to ST through point R. It is given in the question as a hint that draw a line parallel to ST. We have to draw a line parallel to ST and passing through R. So let us draw this line. This is a line which is parallel to ST. That means let us say this is A and this is B. Therefore, AB is parallel to ST. Okay. Now, since AB is parallel to ST, therefore angle TSR plus angle SRB is equal to 180 degree. Interior angle of a transversal passing through two parallel lines on the same side is 180 degree. Therefore, TSR is 130 degree plus angle SRB is equal to 180 degree. So angle SRB is equal to 180 minus 130. So angle SRB becomes 50 degree. So this angle becomes 50 degree. Okay. Similarly, we can say since AB is parallel to ST and ST is parallel to PQ, therefore AB has to be parallel to PQ, because lines which are parallel to the same lines are parallel, right? Therefore AB is parallel to PQ. Since AB is parallel to PQ, from the same reason that a transversal QR is passing through two parallel lines PQ and AB, and this on the same side of the transversal, the sum of interior angles is 180 degree. Therefore angle PQR plus angle QRA is equal to 180 degree. So 110 plus angle QRA is equal to 180 degree. So angle QRA becomes 70 degree, right? So this angle becomes 70 degree, right? Now angle ARS plus angle SRB is equal to 180 degree, because AB is a line and they form a linear pair. Therefore the sum of the two angles is 180 degree, and we can write ARS as AQR plus QRS plus SRB is equal to 180 degree. AQR sorry AQR ARQ 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 is 70 degree plus QRS we have to find, and SRB is 50 degree is equal to 180 degree. So QRS is equal to 180 minus 120. So QRS is equal to 60 degree angle. Always write angle. This is our answer. QRS is 60 degree. Next question. Question number 4. In the figure given below, if AB is parallel to CD, angle APQ is 50 degree and angle PRD is 127 degree, find X and Y. So what is given in the question? This line AB is parallel to CD. Angle APQ is 50 degree. That means this angle is 50 degree. Angle PRD is 127 degree. That means this angle is 127 degree. What we have to find? We have to find X and we have to find Y. Find angle X and angle Y. Solution. It is given that AB is parallel to CD. Okay. And since they are parallel and PR is a transversal which is passing through A and B, therefore the alternate angles of this transversal will be equal, which means angle APR will be equal to angle PRD. Therefore 50 plus y is equal to 127 degree. So y is equal to 127 minus 50. So y is equal to 77 degree. This is our first part. Now, since AB is parallel to CD and PQ is a transversal passing through AB and CD, therefore the sum of interior angles of the transversal passing through AB and CD will be 180 degree, and therefore angle APQ plus angle CQP will be equal to 180 degree. So APQ is 50 plus angle CQP is equal to 180. CQP is equal to 180 minus 50 is 130 degree. So this angle becomes 130 degree. And because of the transversal, because PQ is a because angle CQD forms a linear pair, therefore angle CQP plus angle PQD is equal to 180 degree. So CQP we have find that it is 130 degree plus angle PQD is equal to 180 degree. So PQD is equal to 50 degree. And PQD is x. X is equal to 50 degree. We could have find this. There are many other ways we can find this problem, that when we find y, we can find this angle 180 minus 127, and then we can add the sum of interior angles of a triangle is 180. Therefore we can find x also. There is one other way we can find x, similar to similar to how we find y, that we have the sum of this angle is 70 degree or 77 degree. So we can find the remaining part of this, and we can subtract it from this, from x, right? So there are many ways to solve the same problem, but this was the easiest way, therefore we have approached this. Question number 5. In the figure given below, PQ and RS are two mirrors placed parallel to each other. An incident ray AB strikes the mirror PQ at B, and then reflected ray moves along the path BC and strikes the mirror at RS at C, and again reflects back along CD. Prove AV parallel to CD. So we have here two mirror PQ and RS. A ray reflects along the path AB and strikes the mirror PQ at B, and then moves along the path BC and strikes the mirror RS at C, and then moves along the path CD. So this is the same ray. Okay, so what we will do first, we will write the given things. What is the given things? That PQ is parallel to RS. We have to find AB parallel to CD. Okay, now because these are two mirrors, we have to make some imaginary lines from point B perpendicular to RS like this, and similarly we'll make an imaginary line from point C perpendicular to PQ. This line we will name M and this line we will name N. Okay, so solution: draw line perpendicular to PQ and on RS at point M. Similarly, draw a line perpendicular to RS from C perpendicular to RS and on PQ name it N. Okay, so this will be our two imaginary lines. Since PQ is parallel to RS, that is given, therefore this imaginary line PM will be parallel to CN, because perpendiculars to parallel lines are parallel. Okay, BM will be parallel to CN. Okay, now the ray AB strikes the mirror RPQ at point B. So this AB ray will make an angle, let us suppose X, with line BM. Therefore angle ABM will be equal to X, and from the law of reflection angle MBC will also be equal to X. So the path of this ray, that is ABC, angle ABC will be equal to angle ABM plus angle MBC is equal to X plus X equal to 2X. So angle ABC becomes 2X. Let us assume this is equation number 1. Similarly, since BM is parallel to CN and BC is transversal, therefore it will make alternate angles alternate interior angles equal. Therefore angle MBC will be equal to angle BCN, right? So MBC is X is equal to angle BCN, and similarly, like equation 1, angle BCN will be equal to angle NCD. That means this becomes N, this becomes X, and this also becomes X. Therefore angle BCD becomes angle BCN plus angle NCD is equal to X plus X. So angle BCD becomes 2X. This is question number 2. Now Since from equation 1 and 2, since angle ABC is equal to angle BCD, and angle MBC is equal to angle BCN, this is only possible, and BM is parallel to CN, this is given, we have, this is what we have made, therefore this is only possible, and because the interior angles of a transversal passing through two parallel lines, alternate interior angle of a transversal passing through two parallel lines are equal. Since they are equal, therefore both these lines has to be parallel. Right? Since angle ABC is equal to BCD and BC is a transversal, BC is a transversal of line AB and CD, and since the interior angles, alternate interior angles of a transversal are equal, that is 2x, therefore AB and CD has to be parallel, hence proved. Here we have completed chapter number 6 of class 9th, lines and angles. If you have any doubt, you can contact me on Ankit public 11@gmail.com, or you can post a comment and I will try to answer your queries, or any other question if you have regarding lines and angle, you can post it on comment or you can send me an email. I will answer that. I hope you have understood the concept of lines and angles. Thank you.